Okay, we continue our line class. It's been a long one, so hopefully you're sticking with it. We have one more method left, is perpendicular. And I wanted to do maybe some finishing touches up here, but I think I'll just do the is perpendicular and call it. I suspect, again, that this will, the code itself will be short. The testing might take longer. So let's look at it. I'll put it below is parallel. And again, I want that toString method just to be last. So public Boolean is perpendicular. And line other. So two lines are perpendicular. Let's return false. If the product of their slope is -1. Except unless one of the lines is vertical or horizontal. So that in that case, the product of their slopes will be an AN, not a number. So I think what we'll do is we'll say we want to check if line 1 is vertical. So we have two lines. So we'll have line 1 is the object itself, and then other is the other line. So if is vertical, then it's going to be true if the other line is horizontal. So then we can return other dot is horizontal. And since that if statement is ending in a return, I don't need an else. I can just have another if statement here that says if line 1 is horizontal, then I want to return other dot is vertical. Because if that's true, then the two lines are perpendicular, and if that's false, I have a typo here, horizontal. If that's false, then the two lines are not perpendicular. So now we can assume that the line that we're dealing with is not vertical and it's not horizontal. So then we want to find its slope, which says find slope. And we want to multiply that slope by other dot find slope. I need parentheses around that after that find slope here. So that's a little confusing. So you might say here, this dot find slope, because they're both calling find slope. So that's not a Boolean. That's the product of their slopes. And if that product is equal to -1, that is now a Boolean. If it's true, it's going to return true. If it's false, it's going to return false. And if that product is -1, that's what makes it the line's perpendicular. So that'll return true if the two lines are perpendicular. So we'll say here returns true if the two lines are perpendicular. Okay, so I think that code is done. I think similar to the other codes, it's actually the testing that will take longer. So we'll get back to our client. So first off, let's start with two lines that are not perpendicular. So line 1 and line 4 would not be perpendicular. And I'll just do that code right here and say line 1 perpendicular to line 4, question mark. call the method isPerpendicular here. I need to go line 1 dot. Send it line 4. So this should be false. Line 1 perpendicular to line 4 is false. And then I also want to just, this line 4 was a horizontal line. Well, it shouldn't matter. It should be fine. So now let's make, so line 4 here is horizontal. No, is vertical. Line 4 is vertical. Let's make line 1 horizontal. So this would have the same y values. That would be line 1 is horizontal, and line 4 is vertical. And so those should now be perpendicular. Line 1 perpendicular to line 4, true. Good. Now I want to, so I checked a non-perpendicular. We haven't checked two non. Okay, so now I should do, if line 1 is horizontal, is vertical, so I should make this a 5 and a 9. So now line 1 and line 4 would be parallel, so they should not be perpendicular. Let's see what happens. Notice down here they are parallel, true. Up here they are not perpendicular, false, good. Now I want line 4 to be, line 1 is vertical, I want line 4 to be horizontal, so I'll change this to an 8. So now they should be perpendicular. One's vertical, the other one's horizontal. Line 1 perpendicular to line 4. This says false, so something happened here. Let's print line 4 here so I can see what's happening. Line 4. And again, the testing is taking longer than the actual code because there's so many different cases here. Line 4. Oh, I made a. These are the same point. 1, 8, and 1, 8 are the same point. So it's possible. It's not a line. And so that takes us to that question of like, oh, what if someone tries to create a line that actually has the same 2 points? So it is calling them not perpendicular because I don't know why, but this needs to not be the same point. Let's make that a 3, 8. And again, see how that print statement sort of helped me understand what was going on there. It thinks that's a vertical line, when it's actually a horizontal line. So so now line 1 perpendicular to line 4, true. And actually, I could get rid of all the rest of the testing because I can do all my testing here with line 1 and line 4, and maybe it's easier. But I'm just going to look at that first line. Okay, so we've tested almost everything. Let's go back and make this 5, 8, and 6, 10 again. The original line that we had for line 1, and this should now not be perpendicular. Okay, and now I want to, it's a little trickier than that. Let's make my life a little easier, and let's make this 0, 1. So it has a, or let's make it 0, 0, the origin, with slope 2. So I'm going to go 1 and 2. And now, so that line has slope 2, and I want to find a line that has slope -0.5. So if it goes through 3, 8, I want it to go down 1, so 7, and to the right 2, so 5, 7. So that line 4 will have a slope -0.5, and line 1 has a slope 2. We can see that when we print them out. Line 1 has slope 2, line 4 has slope -0.5. They are perpendicular. Okay, so that function is working. Our client has tested it all the way around, so we're good to go there. you know, we ran into this case where our line, it's sort of not well defined, because we shouldn't be allowed to create a line that has two of the same points. So that would be something that we would need to clean up. The other thing that could be cleaned up is the idea that whether or not two lines are equal if they have the same equation, or do they have to have the same points. So, you know, mathematically, you can represent, you know, a line goes through infinitely many points. So the line is determined by 2 points, but that's not the only way to determine the line. That's not the only 2 points that would determine the same line. So those are the two cases, the two things that we have not reckoned with here. That could be something we put in the comments to explain to whoever's looking at it later. That could be something that we fix. Both those things could be worked out to work. But I think overall we get the idea, and this idea that, you know, a method, these methods can call each other, they can call the other's version of those methods. Regardless of what you do in the class, checking it in the client is really important. What you're trying to do is sort of see if everything works out as you expect, and then you don't want someone using the class to have things crash on you unexpectedly. Okay, so I think that's it. I will do a final sweep through this code. Let's see if I can make this bigger. Final sweep through this line code. We have our class line with our two fields. They're both points. We had a workaround in the constructor so that we're actually individually setting the x and y coordinates of those points, so that changing a point back in the client doesn't change the line. And then we used 3 constructors with a default constructor of no points, a private constructor that creates, you know, an empty line with sort of both points at the origin. Again, that's impossible, but it's a way to sort of have an empty line. And then the second constructor, which has a single point coming in, and that's a line through the origin and that point. Then we had getters and setters for both of the points. Those are pretty straightforward. Then we had a method find slope, a couple of Boolean methods that utilize it, is vertical, is horizontal. Then we wrote a method to find the equation of the line and return it. Along with Boolean methods, equals, is parallel, is perpendicular, and toString. And again, one of the awkward things was that is parallel also has that issue that if it was actually the same line, it's going to return true. So is parallel is actually just returning whether or not the two lines have the same slope. Is perpendicular, we had to worry about the division by 0, because those two things are never going to multiply to -1 for the horizontal and vertical line. So I had to take those into consideration. Otherwise, this one, it works because, again, if one of these slopes is not a real number, we already know the other one's not 0 from this code. So we know they're not perpendicular. So when you multiply them, you're not going to get -1. That's going to return false. And then I have my toString that we modified to also print the 2 points, but also print the equation of the line. Okay, so that's our line object. I think, you know, that does a pretty good, should give you a pretty good idea of what's going on with these objects. I know, you know, one thing I wouldn't mind doing is thinking about objects that have more fields and how those work. But, you know, you have a couple of little assignments on these and a project, and that could be enough for our object classes. And again, next quarter, we'll pick right up with this about how objects in chapter 9, well, I say we, but I won't be there. But in chapter 9, the objects can inherit from their parent object, or you can have sort of relationships between objects. And we'll look at that type of thing. So we'll be doing more work with objects in next quarter, starting with chapter 9, and then we revisit sort of arrays and array lists and linked lists, and we actually end up developing code for all of that stuff as objects. So they're all existing in Java already, but then we write our own code, similar like with the point object that's existing in the Java AWT. It probably has a line thing. I didn't go off of Java's, I just kind of made my own requirements for line. So if I were looking at Java's, the AWT's line, it's probably slightly different, but it has probably a lot of the similar methods. Okay, I think that's it. This could be the last video. Yay. Sorry. I'm sure you're probably, if you've watched them all, you're ready to be done with them as well. I might do another set for objects, but they take a long time. So, and I'm sure you're aware of that. So this could be it. And I want to just sort of say, great work for everyone this term. I hope you enjoyed the class. I have enjoyed it, although it's been tough. These videos, they are time consuming. So I'm sure you know that because if you've gone along with me, you are well aware. So great work, and good luck finishing out. If this is it in terms of another bit, I don't know if I'm going to do another video or not. I feel like it's probably plenty of material for chapter 8. So this could be it, and yay, good job.